Hi everyone, it's me again. Are you someone who keeps dropping stuff everywhere? I'll give you a few seconds to think about it. Well, I personally don't, but today I'm going to drop things deliberately and tell you the science about it with the help of this instrument. Who knows dropping stuff could be so useful? Just a spoiler. The keywords today are adhesion, interfacial energy, and impact. Let's have a look at the setup, shall we? What we want to do today involves a high-speed camera. The device we have here is capable of taking high-speed video up to 1 million frames per second. It is equipped with a zoom lens here. The next thing we have is a light source that is used specifically for high-speed imaging purpose. A friendly warning here, don't stare right at it when it's turned on. The next thing we have is a test rig just like this. It's got a ruler, a hollow tube, and a base with a hole right at the center. What we have next is SCM sample stop. And we are going to drop the SCM stop right into the hollow tube. Just like this. But of course, we are not just going to drop the SCM stop. We're going to drop something else alongside with it. Our experiment today is about characterizing the adhesion of powder on the substrate. What I'm going to do next is to disperse some powder onto the SCM stop with the help of the morphology G3. Let's put the SCM stop on the glass plate and tell the morphology G3 to disperse some powder sample on it. While waiting for the dispersion to complete, let's revisit the idea on how we can make use of drop tests to characterize the adhesion of powder on the substrate. Basically, after the dispersion, what we are going to do next is simply dropping the SCM stop inside the hollow tube, with the side where we have the particles facing downward, like we illustrate here. Particles sticks to the surface of the SCM stop due to adhesion. After the impact, this is what will happen. Bigger particles fall off and the smaller ones stay. At the instant of impact, the SCM stop experiences a short period of deceleration, and that generates a tensile force between the particles and the surface of the stop. The competition between the force of adhesion and force of detachment will decide which particle survived the impact. The adhesion force is calculated based on the Johnson-Kendall-Roberts theory, while the detachment force is based on momentum. Having a knowledge of the size of the particles sticking on the SCM stop prior and after the impact is very useful. As I mentioned earlier, bigger particles would fall off and the smaller one would stay. Therefore, the first thing I would do after the dispersion is to measure the size of the particles that are sticking on the SCM stop. Again, that can be done using the morphology G3. Once the size measurement is done, all we need to do is to drop the SCM stop into the hollow tube, the way I showed you earlier. But this time, we have both the light source and the high-speed camera ready to capture the glorious moment of when the SCM stop and the base meet. Don't blink your eyes, here we go. Well, maybe it's not that fun to look at after all, but nevertheless, we can extract a lot of information from the high-speed video that we just recorded. This is an example of the high-speed video capturing the moment of impact. Since we know the distance to pixel ratio and the time difference between each frame, we can calculate the impact velocity of the SCM stop as well as the contact time for deceleration easily. Now, the parameter that we are really interested in is the interfacial energy, represented by the Greek symbol gamma. At this stage, we have all the variables we need, apart from the radius and the mass of the critical particle size. And that can be obtained by doing another size measurement of the particles remaining on the SEM stub after the impact. By averaging the smallest particle size that has been detached from the substrate and the biggest particle size that remains on the SEM stub after the impact, the critical size can be obtained. Having this information, we can now estimate the particle mass and subsequently fulfill the equation above and calculate the interfacial energy. Now, even though the impact velocity is influential on the critical particle size for detachment, the interfacial energy is not affected as much, showing the robustness of this technique. Drop test method is sensitive to the particle morphology and roughness. The surface properties of the substrate is influential too. Here, I would like to show you some results. Different powders are measured against a glass substrate. We can see that by using drop test method, the interfacial energy between different materials pair can be characterized. The technique can nicely differentiate the interfacial energy of different materials, even within the same sample but of different grades. Just to conclude, the drop test method is a cheap and easy technique for measuring particle adhesion. This is the last demo of this workshop. I personally think the demo videos nicely complement the lectures, and I hope to share the same feeling and learn something useful. Adios, I'll see you next time.